Hi everyone, this is another of the RavenDB's screencast, and today I'm with Phil Jones from Orange Lightning, and Phil is actually working on an interesting project right now, Escape Trips, and basically we're going to take RavenDB into its own Stag party. Hello Phil, how are you?
Hi, Aidan. Yeah, I'm fine.
I'm very happy to hear that, and I'm going to move the screen to you, and you can show us exactly what you're working on, and then we can discuss any problems, the problem that we're actually here for, the complex searching issue.
Okay, so the problem I'm working on is migrating a client's Stag and Hen website from ASP.NET MVC1 and SQL Server to version 3 of ASP.NET MVC and RavenDB.
Awesome. And I know what the stag party is, and hen party is basically the same thing for girls.
Yeah, they go on nighttime activities and daytime activities to celebrate getting married.
Okay.
So it's quite a big business
Okay.
area to work in.
Yeah, I imagine so. Okay, so this is the website, and what is the problem that we actually got here to talk about?
Okay, so this is the public-facing part of the website, which works fine, and our main problem I came up against today is actually searching the data that we collect for the admin side.
Okay.
So a little bit of background is that when somebody submits a request, an inquiry to the website, it's entered into our system in various means, and we end up building what we call a proposal for them, which is what they're going to do kind of on their Stag and Hen do website, Stag and Hen do night out, like if they're going to go to certain clubs and where they're going to stay. So we end up with this kind of screen listing these proposals.
Okay.
And I want to kind of let the admins search through them in a kind of an intelligent way, because departure dates can be anywhere from 6 to 8 months in the future, and there's often many proposals before the client accepts one and pays for it.
Okay, so let's think about this for a second. So we have, right now, by the way, I'm not actually going to discuss about any of the RavenDB details, just the user experience details. So I, as the customer, contact you somehow, and you make me several proposals. So go to London and visit a pub, or go to Aruba and lay on the beach, those sort of things, right?
Yep.
Okay. Now, when you say that a single customer may have many proposals, what is many? Are we talking about 3 or are we talking about 500?
Often less than 10.
Okay.
It's normally done in about 5 different proposals.
Okay, that's great. And the reason that I'm asking that is that it makes a lot more sense to actually think about, because if you said, okay, we have 500 or 5,000 proposals per customer, then you actually care for, then the sort of UI metaphors and user experience that you have to provide is drastically different than if you have 10, 20 proposals per person, per customer. How many customer? So is it common for a customer to show up multiple times? If, for example,
A customer multiple times. Oh, do you mean like go on several Stag and Hen do?
yes.
It's very rare actually, because it's normally they book it themselves.
Okay.
But there are the odd occasions where somebody will then book it for a friend and they take charge of it, but
Okay.
not very often.
So most of the time we're not talking about repeat customers. We're talking about customer count, go on, and we can, so that affects the way that we can think about the problem. So one of the things that we've discussed over in the main list is that you wanted to allow them to make a search such as Allende London or Allende May 2012. Those sort of things, right?
Yeah, because it kind of often they'll just remember like the first name, the
Mm-hmm.
name of the customer, and when they're going. So if they want to, so one screen we're planning on adding is adding a screen where all the Stag and Hen dues that are leaving today are shown, for example.
Mm-hmm.
So it would make sense if they could search, like IND 16th to the 1st, 2012 to see
Okay.
that proposal.
And where is this departure date is actually located? So we
Uh,
have
that is that is stored on the proposal document.
okay. So we have the notion of we have a customer document. And we have several proposal documents to look at, right?
Yep.
Okay. What we actually want to do is to provide good search experience. So, and the reason that I ask all of those questions is that the amount of data that we expect in the common case impact the solution that we have. For example, you would have told me that if this was actual travel agency, then you may have a customer that, for example, if you're the travel agency for Microsoft, the client is Microsoft, and they have, hundreds or thousands of people that travel all the time. So that would be a very complex thing to do. But what we talk about is relatively modest amount of information per customer, and that information usually doesn't aggregate over time. So given that, let's look at the customer and let's look at the customer document, and let's look at a proposal document.
Okay. So custom document. I'll have to drag this off screen. Okay. So this is a customer document.
Okay, so it's a fairly simple one. And let's look at the proposal. Can you just open a new tab and let's look at the proposal document?
Okay. So this is a proposal document for that customer.
Okay, so let's look at that. Okay, now what are the actual things that we care to search for in here?
They tend to search for the customer's name,
Mm-hmm.
their email address, and normally the departure date.
Okay.
Those are the three bits they normally search on.
Okay, can you go up a bit? Do we care for the location that they're going in? So would you want to say I am the Birmingham or even Birmingham in this case?
No, because they've always assumed that what they can search on is what they can see.
Mm.
So I think it's safe to say that they'd only search on information that's shown here.
Okay, okay. So given that amount of information, let's think about a solution. We want to take information from two different documents. That calls for us to build something that is called a multi-map index. Can you switch please to Visual Studio? And let's create a new index that would satisfy the requirements that you specify.
Okay, so the index powering that screen at the moment is this one, which was shown on the mailing list.
Okay. Let's just delete the. So let's do this like this. Let's delete the transform results. Oh wait, do we? Wait a second. Wait a second. What is this thing? The transform result. This is what you wanted to be able to search on, right? Or is this actual the stuff that you get back that you want to work with?
This is what powers the search view, so it is called here. So if I open the controller,
Mm-hmm.
so this is the method that calls it.
Can you give me a second to look at this? Proposal, yes, proposal, list view item. Okay, that's fine. Okay, so let's go into the proposals list projection. And let's do this like this. We're going to keep the transform result as is. And we're going to delete the map. And can you move to full screen? Just Alt Enter should do it.
Hmm. Alt Enter doesn't seem to do it. Shift Alt Enter.
Okay, great. So now, okay. So the problem right now is that we're actually inheriting from the wrong base class. We're inheriting from abstract index creation task, and we need to inherit from abstract multi-map index creation task.
Like that.
Yes. Okay. And it doesn't inherit. It doesn't remove the generic thingy there. Okay. Wonderful. So, what we want to do now is to actually get start by querying by getting the information that we want from the customer. So on line 13, let's do add map of customer. And customer, no, for customers. This is a lambda. You need customers and then the lambda arrow. No. Change the X to be customers. Okay. Now the lambda arrow. From customers from customer in customers. Okay. And now the question here, what are the details that we actually want to select from from the customer? We want the customer name and we want the customer email, right?
Yep.
Okay, so let's output those in the select.
That's actually username and name.
And email.
Their username is actually their email address.
Okay, okay, that's fine. So we have those things, and that's what we want from this customer, right? We also need the customer ID. Okay. Now we want another map for proposals. And now we need to do select. What are the details that you want to select from this?
That would be the departure date. You probably want the ID.
And let's put the location as well. They might not search for that now, but it's nice to have it. Okay. Now, here is one problem that we have. The output of both map items, both map functions has to be the same, both in type and intention.
Kind of like union in SQL Server.
yes, very similar. So let's start from the customer. Instead of having customer.id, let's name this field customer ID. And we actually have a proposal.customer.id, if I remember correctly.
Yes. It calls it custom user ID.
So okay, so let's add proposal.customer user ID to the output of the proposal as well. And now we need, so you see that we have a proposal.id here. We need something similar in the customer as well. We don't have anything to put there because customer doesn't have any proposals association there. So what we're actually going to do is to create a proposal IDs collection which is empty. So just proposal IDs equal new empty string array. No,
Like that.
string array. And 0. Okay, so same thing, we're going to create a proposal IDs field which has the proposal ID, only the proposal ID in it. Okay, but wait a second, they have to have the same type. So it has to be a string array. Exactly. Okay, so we solved the problems of two fields. Now we have customer username and name that we want to include. Now, the interesting bit about this is that we don't actually care about their value. We only care that they would be searchable, right?
Yes.
Okay, so let's create a new field. Let's call it query. And that
Which the
on the customer. Let's start with customer. And that would be an object array. which would include the customer username and customer name. Okay, now we can delete the first 2 lines, the previous 2 lines. Great. Now, we also need this for so the next thing that we need to do is to actually look up do another query for the customer as well, for the proposal as well. So we create a new query, the proposals, yes, new object array. And then we put the things that you want to index. Can you make them on different lines? Okay. Now delete the previous 2 lines. So far, so good. We have a problem, however. And that problem is that the departure date is actually daytime. That is a horrible format if we want to actually search for that. So let's do proposal.departuredate.toString. And let's provide, sorry?
I think that's a nullable date time.
So just do that with the, so go up on the, I hate doing that. Go up to the form line and add the let statement. Oh, you know what? No, let's do where. No, yeah, there. No need. Let's let departure equal proposal.departure date, non-coalescing operator, mean value. No, equal sign.
I've never come across this before. New?
No. Proposal dot departure date. Question mark. Datum dot mean value.
New value.
Mean value.
Min value.
Is it possible that the departure date would be null?
Yes, that's a throwback from the old system.
Okay. So now let's look at the departure down below. And now instead of departure date, let's do departure.toString. And now let's see what sort of formats do we want to allow. I think that doing something like MMM, YYY would be reasonable. Or just MMM space YYYY. Shouldn't this be capital letters?
I can never remember.
Yeah, 1 second, I will check. Yeah, it should be capital letters MMMM and then lowercase YYYY. It should be 3 MMM. Okay, so that would output values such as January 2012. That is, now we also want to allow them to search for a specific date. So let's add another line to this array with a different format. So departure to string. Are you always going to use the UK formatting for the system?
Yeah, they normally search like this,
Okay.
which is day, day, month, month, year, year.
dd/m slash capital M slash yyyy. But are you using two-letter digits for the? You know what? Let's add another two lines with this exact same thing, but we don't even need to do that. You know what? Yeah, we could, but just no, we don't need to do that. Let's do something else. Uh, no, you know what? Let's keep it this way. It's easier that way. Uh, do we want to provide them with the ability to also do that for uh, two digit tier numbers?
Two.
So January 1, 2.
No, I'm pretty sure the day, day, month, month, year, year, year
Okay.
is fine.
Okay, so
That's what they normally search with.
okay, so that's great. Now, what we actually have now is a list, is something that is actually very interesting because this is basically just a union, but it doesn't give us the information that we want because right now we have unions of customer information and proposal information, but we actually need to group them together. In order to do that, we actually have to group them together. So before we can do that, we need to define, because we're working on the client side here, we need to actually define a class that has the same shape as the output of those map statements.
Right, okay. Okay, so I have that.
Okay, that's great. Uh, Almost okay. We're going to cheat a bit. No, we're not going to cheat. Let's just do it like this. So now in the class declaration, let's inherit for abstract multi-map index creation task of a proposal list search.
Yep.
Okay, great. Now we're going to add a reduce statement. And result lambda from result in results. Now, we need to actually group the results its results in the Lambda. Yeah. So now we're going to group all of them, group result by result customer user ID. And into G. And now we need to output exactly the same shape as we have been given. So select new and customer user ID equal g.key.
What about proposal IDs?
And g dot select many. X dot proposal IDs to array. And exactly the same thing for query. Great. One last thing that we want to do, we want to make the query to be a, we want to make the query a full search, to allow full text search indexing over the query. So on line 44, let's add an index. No, just index. Yeah. Now, x, this is a method. So x lambda x dot query. And now, now field indexing dot analyzed. Yeah, wonderful. So final thing that we need to do is that the transform result is now broken because we no longer get proposals. We get the value from the reduce. So let's change the name for the proposals variable. Yeah. Okay. Now, form result in result. That's good. So the customer line should be result dot customer ID.
Customer.
No, like it was before, but instead of proposal dot customer,
I see. Yeah.
just result dot. And I don't know what admin user ID means.
Admin user is, they don't search on it, but it is this one here. So the proposal documents are associated with an admin user, which is the member of staff that added them.
Okay.
So you can see.
Okay, so what we're going to do actually is quite interesting. On line 48, from one down, and okay, another one. Let's create a new line. From proposal ID in result.proposal IDs.
Proposal IDs. Sorry, I don't follow.
From proposal ID in result.proposal IDs,
Oh, I see, yeah.
let proposal equal database.load proposal ID. Can you change so the P there is lowercase? No, no, no. On line 50, on line 51. Yeah, that one. No, just the proposal ID though. Yeah, that's the, yeah. And fix. And now we need to take the admin line and put it below the proposal. And I'm pretty sure we're done. Okay, so what we have actually done is to expand the search capabilities of this index. And based on the output of this index, which is actually a multi-map reduce index, we apply a transform result to get the actual get the data in the shape that you actually wanted. Okay?
Yeah, that's...
Wait a second. We don't know if it works yet. Okay? Let's go to the proposal controller. And where do you have the actual search?
I haven't written that yet.
Okay, so let's just add the string query. Yeah, exactly. And let's just extract the extract just the session.query. Extract the session.query into a variable.
I was going to write it like this.
And it has to be before you do the. No, it has to
Oh,
be
it has to
before
be
you do
before
the.
as.
Yeah.
What do you mean by extract?
Just move the session.query into a different line and put it in a variable. var q equals session.query. Now, this is not proposal now. We're not querying on proposal, we're querying on proposal research. Because that's the output that goes into the index.
Yeah.
Exactly. And no, no, no. Now we need to do the if blah blah. If not is now empty. That wouldn't be it. Okay? That would be good if you wanted to do an exact match. But we're actually going to do a search, which is more complicated than just a match. So instead of doing rq.where, doing rq.search. Exactly. Now x.query, comma query. That's it. And now line 35, replace the session.query with rq. You're missing proposals. On line 35, it started with var proposals. And then on line 46, replacement proposals, yes. Oh, interesting. We don't have created in there. See that?
Yes, because yeah, the
We didn't
few.
we didn't add it into the actual document. Now we need to add created to all of them.
To even the add maps, or
Yeah, to both maps. hmm No, not here. Down below. Okay, great. Now we need to add it to the reduce as well. And in this case, this brings up an interesting question. What is actually the created date when we have multiple of them? And I think just the most recent one would suffice. So g.max, okay, and that's great. And everything should now work. What?
oh, just ignore this. This is a code rush issue. I
Okay.
reported it, but it doesn't seem to like RavenDB code much.
Okay, I don't like Kodash anyway, so we're even. Yeah. Okay, so let's try to run things.
Okay, it's building. Succeeded.
Now let's see if this actually works. Da-da-da-dum. Da-da-da-dum. By the way, I'm presuming that you have, yeah. So you set up the application to recreate the indexing in the startup,
Yes.
and we can see that right now the proposal index is actually stale. There isn't
Yeah,
anything there. We
I've
just
got it.
created that. Yeah. So let's go to RavenDB for a second, and let's look at what's actually going on in there.
50 errors.
Yeah, that's interesting. Oh, okay. Yeah, that's actually a bug in the way that RavenDB does. What's it called? The way it translates the values. Go back to the code. I'm pretty sure we actually fixed it in 599, but never mind.
Yeah, I'm running on 573.
Yeah. So go to the proposal list projection and go to the reduce. To the list projection, please. Go to the reduce in the max. Cast it to daytime. No. Actual cast inside the lambda.
Like
Yes.
that.
Yes. This is stupid. We fixed that, but right now, for your build, we actually need to do that. Okay. So let's run this. Now let's go to RavenDB again. See if we still have any errors.
Nope, it's not stale anymore. No errors.
Okay, that's awesome. So let's go to indexes, and let's go to this index. Now, did you know what? No, go back. We want that one. Did you know that this has intelligence?
No, I did not.
Do a control space.
Oh, that's impressive.
Yeah. Let's select query. And control space again. Okay. So you can see that we have lots of stuff like that.
Whoops.
So let's just for even. Control enter.
That'd be...
No, just like that. Control enter.
Yep.
Now, don't go into them. Yeah, just like that. Exactly. Because there is a bug that if you go into them in this build, it breaks. The UI breaks. Just
Doesn't
expand.
seem to...
No, expand them higher. There you go. Okay. So now those are the actual result from the index. This is because we have taken the reduced result of this index, and then we apply the transform result on that, and then we get this thing.
Right, yeah.
Okay. And now if we go to your application and we hack the URL so we can get to the proposal list, then we can actually try to see what happens when we try to do actual results.
Oh, there we go.
And let's try to do even October 2010. No, just Oct. Because that's the only thing we gave it. Okay.
Yes.
Now, notice something quite interesting. You see that you see other dates as well?
Yes.
That is because those are for people that have multiple departure dates.
Ah, yes, yeah.
Okay. So you might want to do an additional filtering because right now we're just trying to find the actual values. But I think that this is more than sufficient enough to actually give you the result that you want.
Yes, yeah. So what did we include? Location name. So in theory I should be able to type. I'd have to verify that, but it looks like it's working.
Mm-hmm. I really like doing this sort of things. Okay, so let's go into the Visual Studio one more time. And let's go into full screen mode, please. So I just want, so go all the way up. I just want to go over this index one last time because it's a small class, but it does a lot of things. Okay, so you can see we inherit from abstract multi-map index creation task, and we are actually indexing both customers and proposals. We get the same shape of the data from both of them. Then we actually reduce this information to group the information from the customer and from the proposal into single result. And this is what happens during the indexing phase. We also, another thing to remember is that we're actually allowing the querying over multiple fields in a very easy manner. We also say that this query field is actually we're asking it to be analyzed, so we enable full text search on that. Finally, after we've issued the query and got the results from the database, then we're actually going to run the transform result stuff. And the transform result stuff basically take the reduced result from the database, load the customer ID, load all of its proposals, and send all of them back to you in a single router to the database, including getting related information, also all of those sort of things. Okay, you follow what's going on?
Yep.
Yeah. And I'm really happy that it works. I mean, I just, sometimes you get so caught up in actually building the features, and then you actually see the feature being used, and that's wonderful.
Yeah, it is a very impressive database system.
Yeah, thank you very much. Do you have any additional questions?
Well, yeah, I have lots of RavenDB questions, but it probably takes several hours to cover all of them.
Okay, so maybe we do another screencast, another webcast or screencast in the future. We're more than happy to do that. They are fun.
Yeah, I can apply that to other areas of the system now, because inquiries is a similar scenario, where you have an inquiries document and a customers document, and that would really help, because at the moment you can see I have this horrible search thing here, and it'd be good to actually...
Void? What does it mean to be void?
Those are just classifications for if somebody's inquired.
Okay, yeah, it doesn't matter. Business meaning.
Business logic.
Yeah, those sort of things. Okay, wonderful. So thank you so much for the interesting problem. And I hope that let me know when you go live with the new website. It would be great.
Yeah, the plan is start of February, so...
Okay,
yeah.
Wonderful. Okay, goodbye.
Okay, thanks. Bye.